Hi guys, here's our next lesson for extension. Now, what we're doing today is basically factorising polynomials. It's really just building on this long division that we did last lesson. This is a pretty big lesson, okay? So it's going to take a while. I'm probably going to have to split this up into a couple of different videos. There's a lot in it, but it repeats a lot. So let's start right from the beginning. And here's a nice little just a nice little rule that we find out. It's that if polynomial px is divided by x minus k, then the remainder will be the function of k. So what it's actually saying here is if I divide this polynomial by x minus 2, then the function of 2 will be the remainder of this polynomial. So let's have a go. So if I substitute the function of 2 into this, 2 to the power of 4 minus 2 squared plus 5 2 plus 1. Now, because this is so big, I'm just going to pause it, okay, and work it out, and then I'll show you. So just basically substituting that in and working it all out, the function at 2, sorry, this is one I did before, you'll notice that it's actually different. I wrote P2 instead of F2, ends up being 51. So from this we can say that the remainder, when we divide that, rather than going through all of the effort of the long division, all we have to do is substitute k equals 2, or I should say 2, into the function, and we get our remainder. So the remainder is 51. Now, we can take this further and evaluate m if the remainder is 4 when the function 2x to the power of 4 plus mx plus 5 is divided by x plus 3. Now this sounds complicated, but we know that the function of x minus k, and in this case it's x plus 3, so k would be negative 3. So the function of negative 3 equals 4. So we see here that the function of negative 3 equals 4. So what we want to do now then is, if we know the function of negative 3 equals 4, we've only got one unknown missing in this function. So let's substitute all of that in. 2 to the power of 4, or should I say 2 times negative 3 to the power of 4, I mean to say, plus something times negative 3 plus 5 equals 4. And we can just simplify this. We can simplify this out. Now, pause now and give it a go. Okay, just pause it now. Pause it. Again, not sure why I paused. Feel free to go through and have a look. All I've done is I've just evaluated that and I've solved for m, because I've got everything else there that I need, knowing that k, in other words, was minus 3, and the function of k, in this case, which is the name, is 4. And so we end up working out that m is 162.13, or we can simplify that, or should I say put that as a mixed numeral fraction. If we take that to the next level then, the factor theorem says that for the function, or for the polynomial x, if pk equals 0, then x minus k is a factor of the polynomial. Now let's look back. What exactly does it mean to be a factor? So in this case, it's saying, well, polynomial x, what are the factors of it? Let's say polynomial a let's say a times b equals that. Now we're trying to figure out what polynomials are a and what polynomial is b. Okay, and we're effectively just pulling it apart. We're dividing it through. And so if we have a look here at this question, show that x minus 1 is a factor of polynomial x. All I need to do, well, I know that if I substitute, if x minus 1, or k, if k equals 1, if I substitute the function of 1, I should get 0. Let's have a look. So in this case, k equals 1. Therefore, the function of 1 should equal 0 if I am showing that it's a factor. Now let's substitute that sucker in. If you want to check, pause. I would recommend with all of these that you pause and give it a go yourself. Have a go. And we see that it does work out beautifully, and therefore 1 is a factor of, should I say, x minus 1 is a factor of polynomial x. So now we're asked then to divide the polynomial in the previous question, polynomial x, by x minus 1, and write it in the form polynomial x equals x minus 1 times q. So in other words, all we're doing here is we are dividing polynomial x, which is in the previous question, by x minus 1, and we're seeing what the quotient is. Hence, they're very cheekily put q there. What is the quotient function? In other words, q times x minus 1 should equal polynomial x. Pause and give it a go. See if you can figure it out. Now that you've done it, all we're doing here, it's the same old stuff we did last lesson. X cubed minus 7x squared plus 8x minus 2. We're dividing it by x minus 1. Bada bing, bada boom, bada bing. And we're seeing that x squared minus 6x plus 2 times by x minus 1 will give us polynomial that we're looking at. Now I can just rewrite it this. Px equals x minus 1 times by x squared minus 6x plus 2. That is in the form dictated by the question. And here we have the stinkiest type of question that you might get here. And I only say it's a stinky question because it is something new for us. Okay, it's challenging. And it's also a style that repeats. You will see a lot of this sort of stuff. And they're all very similar, but the first time you see them, they're quite a mission. What we want to do is we want to write this polynomial in the form of that. Now what we see here is we've got a x cubed plus b x plus 3 squared plus c x plus 3 plus d. Now somehow we need to make a link from that to that. Now some of you might already see a few little linky bits there. If you want to give it a go, pause now and have a crack. See if you can suss it out for yourself, or at least part of it. Okay, it's always better to have a go and learn after you've had a go, because then you know what sort of questions you need to ask. What I'm going to do now is I'm going to play around with this a little bit, because I want this to look kind of like that. And so what I'll do is I'll say, well, okay, ax cubed, well, that's pretty much just by itself, plus bx plus 3 squared. So that's going to be bx squared plus b times 6x plus b, or should I say times 9, I'll just write 9b for ease there, plus cx plus 3c plus d. Now, this is the bit that I think takes the bit to get used to, because what we can do is we can break up this polynomial into the terms